All right, so we've got a new lesson now. We're talking about lines that are parallel, and we want to prove that those lines are parallel. Okay, and so your learning target is I can use the angles formed by a transversal to prove two lines are parallel. All right, so what we're doing is we're kind of taking things backwards a little bit. We had some angles that were formed, and we were given that lines were parallel, and we had to find those angle measures. Now we're kind of doing it backwards. We're given parallel lines, or we're given angles formed and those measures, and we have to prove then that those are parallel. Okay, so let's get going on a few definitions first. All right, so let's first take a look at a definition. This is a pretty simple definition. The converse of a theory just means the opposite of the original theory. The opposite of the original theory. So if we had a theory, we're kind of working backwards in order to get to prove that same theory that has already been proven. Okay, so your key concept here is, remember we were talking about corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, all those different things. We're kind of working backwards here. So let's just look at a few of these real quick. It says if two lines are cut by a transversal and the corresponding angles are congruent, if they are congruent, okay, so that means we do have corresponding angles, they are congruent, then the two lines are parallel. Okay, so nothing really tricky there. Again, if we have two lines that are cut by a transversal, and the alternate interior angles are congruent, okay, if they are congruent, then those two lines have to be parallel. All right. Same goes here with if we have two parallel lines that are cut by a transversal and the alternate exterior angles are congruent, if they are the same, then those two lines must be parallel. I'm going to slide down just a little bit real quick. And the last one, if we have two parallel lines that are cut by a transversal and the sum of those two same side interior angles add up to 180 degrees, then the two lines have to be parallel. Okay, here we go. All right, we're going to do an example now, and in example 1 says that if the measure of angle 3 equals 4x minus 80 degrees, and the measure of angle 7 equals 3x minus 50 degrees, and the value of x is 30, then we need to prove that lines L and M are parallel. Okay, we have lines L and M here. We don't know that they're parallel, but what we do know is that the measure of angle 3 right here is 4x minus 80 degrees, and the angle 7 right here is 3x minus 50 degrees. Okay, and we can see that the angle relationship that these two angles make are corresponding angles. So if they are the same, then these lines L and M will be parallel. Okay, so we need to say then that we've got the measure of angle 3. We're just going to guess here. If that is measure of angle 7, not 3. If those two are equal to each other, then we have parallel lines. All right. So let's go ahead and we're going to substitute what we know for these two angles in and then solve. We know measure of angle 3 is 4x minus 80 degrees. And that should equal 3x minus 50 degrees. Now the nice thing is they already told us the value of x. If we were to solve this, we would get x equals 30. So they already told us the value of x is 30. So we're just going to plug in 30 then to both sides, wherever x is. 3 times 30 minus 50. Now we just have to solve and make sure that those two sides of the equal sign do equal the same amount. Okay, so 4 times 30, 4 times 3 is 12, and we add a 0, so we have 120 minus 80 equals 3 times 30 is 90 minus 50. And we know 120 minus 80 is just 40, and 90 minus 50 is also 40. So, yay for us, we have parallel lines. Lines L is parallel to M. I should make my L's pretty like they do. All right, let's do example through 2. All right, example 2 says, same type of thing here. If the measure of angle 2 is 10x plus 8 degrees, and the measure of angle 3 is 25x minus 3 degrees, and the value of x is 5, we need to prove that lines R and S are parallel. So we're trying to prove that R and S, those two lines are going to be parallel. So let's take a look here. Angle 2 is right here, and angle 3 is right over here. And we know these are same side interior angles, and what we know about same side interior angles is that they add up to be 180 degrees. So we know that the measure of angle 2 plus the measure of angle 3 should equal 180 degrees. It should. If the lines R and S are going to be parallel, we need to prove that they should equal 180 degrees. So let's plug in our values in for each of these. We're going to take 10x plus 8, that's what the measure of angle 2 is equal to, plus 25x minus 3, that should equal 180. Let's make sure this is true. Let's combine like terms. 10x plus 25x is 35x, and 8 minus 3 is positive 5 still. Okay, now remember it said up here that the value of x is already 5, so we can just plug in 5 for x and then solve. So we got 35 times 5 plus 5 should equal 180, and now we just have to do a little bit of solving. Now 35 times 5, ooh, that's a little bit harder, but I do know that 35 times 2 is 7, and 35 times 2 is 70, and 70 times 2 is 140, and so we just have to add another 35 to that, which is 175. 175 plus 5, that needs to equal 180, and most of you guys already see it now. 175 plus 5 is 180, and we are happy. These two lines then, lines R is parallel to line S. Cool? Alright, one last example. Alright, example 3 says that using the diagram we're going to prove that lines L and M are parallel given that lines P and R are parallel and the measure of angle 1 and angle 3 are congruent. Okay, so in this diagram here it says that M and L are parallel. We're going to go ahead and assume that those are not parallel lines. We're just going to assume that for now, okay? And we want to prove that they're parallel given that we already know that lines P and R are parallel. Okay, so we're going to write down what we know. And we know that P is parallel to R. That's what the problem gives us. We know that because it's given. And we also know one other thing. We know that the measure of angle 1 is congruent to the measure of angle 3. And we know that because these are, that's also given information. We don't know just by looking at it, but it tells us in the problem that those are congruent angles. Okay? All right, so let's go ahead and try and connect here. We need to try to connect 1 to 2. We can see that they are corresponding angles, but corresponding angles don't necessarily mean that they are the same if we don't have parallel lines. Okay? But what we do know is because these two lines are parallel and this line is a transversal, we know that lines 2 and 3, or those angles, measure of angle 2, is going to be congruent to the measure of angle 3 because of alternate exterior angles. We know that has to be true because of alternate exterior angles. Okay? And then what we're going to go ahead and do here, this fourth thing then, is that if these two are congruent, we already said that 1 and 3 are congruent, that the measure of angle 1 has to be congruent to the measure of angle 2 based on just pure substitution, right? If measure of angle 1 is congruent to the measure of angle 3, we can just take this, plug it in for this, and we end up seeing that those are true based on substitution. Okay, and the last thing that we can say then is that lines L and M, L is parallel to M because of congruent corresponding angles. Alright, last example. Alright, this last example says that a carpenter is creating a woodwork pattern and wants two long pieces to be parallel. The measure of angle 1 is 8x plus 20 degrees, and the measure of angle 2 is 2x plus 10 degrees. if x equals 15, we need to show that these piece A and piece B are parallel, okay? And so I'm going to just get you started on this, and I'm going to let you guys do this on your own. But I want you to prove to me that the angles 1 and angle 2, using that information, that A and B, those two pieces, are parallel. So my question is, to help get you started, what is the relationship between angles 1 and 2? All right, good luck. I hope you do well. Thanks.